Continuous deferred life annuities. For this deferred life annuities, it is similar to the case of the whole life annuities. It's just that the payments now is deferred or postponed for n years. Let's say the deferral period is n years. So for this deferral period, there will be no payment. And then the payment will start from here up until infinity, whole life. So here there will be annuities payment. Since we know that the payment will only be made after n years, so the presence value of the random variable, we can write it as 0 from 0 to n for the future lifetime is lesser than n, and then it's gonna be a bar tx minus a bar n for tx greater than n. Why we have a bar tx? Because here it will be depending on whether survive or not. If the person is surviving, then only the payment will be made, and then we are minusing a bar n because here there are no payment. To find the expected value of this is also similar to the previous whole life deferred and whole life annuities, which is for whole life annuities you are doing the integrations from 0 to infinity, but now you are integrating from the starts of this period, which is n to infinity. Vt tpx dt. It has a actual notation. We have it n deferred a bar x. N shows the deferral period, where x is the age. Bear in mind, we are using $1 as the payment, so we did not write anything. If the benefit or the payment is more than $1, then you have to times the amount of the payment over here. For this case, if you are looking for the variance, you have to find the expected value of the y square. We didn't really have the direct relations like what we have for the whole life and for the term insurance. So you have to differentiate, you have to integrate the second moment, so which you are going to get n to infinity, and then here minus a bar n second moment dpx mu x plus t dt. And then once you get the expected value of the second moment, then you can get the variance, which is second moment minusing the first moment square. If you have the deferred for temporary annuities, for examples, you have annuities up until n years, and then it is deferred for m years. Okay, so let's say it is deferred for m years, no payment, and then it is an annuity up until n years. So here we are going to have from here to here, which is n years, so m plus n if it is the timeline. So let's say the age is x. For examples, you have m deferred a bar x n. So this is the term. This would be the age when he bought the payment of the annuity once entered into the contract, and then here would be the deferral period. Okay, so for this case it's still the same. Yeah, you are going to do the same for the APV. You can get the APV here from the whole life and also from the term minusing this term. Okay, for examples, EY for this case it will be A bar M plus N, and I'll put the H X M plus N minusing A bar X M. So that means that you are taking the whole period here, present value, minusing this small period, so you are going to get the present value for the leftover period here. Okay, that's it for the deferred whole life annuities. Thank you.